Here's our 8th example for taking a derivative using the power rule. For this one I thought I'd go a little crazy. So look at our exponents here. I have exponents to 2/3, I have exponents to 2/5, exponent to the first, crazy little constant there. The other thing that I want you to take particular attention to is this function, this expression is already in terms of dy dx. It means I've already taken a derivative to get to this step. I can go to a second derivative, and again we're just looking at notation here. This is a d squared y dx squared. This is the notation for a second derivative. To do a second derivative, it's just like doing the first derivative. I'm going to use my power rule. 2/3 times 9 gives me 6. X 2/3 minus 1 will go to the negative 1/3. And then for the next step, I'm going to have this 2/5. 2/5 times negative 1/2 becomes negative 1/5, because those 2's would cancel out. It leaves me with a negative 1/5. And then I have to subtract 1 here. So 2/5 take away 1 is negative 3/5. Derivative of 3x is just 3. A derivative of a constant drops out, it becomes 0. And then I want to look at dropping the terms down. And again, when you drop a term down, make sure you understand who owns the exponent. This x is the owner of that exponent. The 6 has an exponent of 1, so it's not moving anywhere. And so as I drop that down, it becomes 6 over x to the 1/3 minus 1 over 5x to the 3/5 plus 3. Again, the x dropped down here. The 5 was already in the bottom. That's why that was written that way. And then there's your answer. That's your second derivative.